Let's continue our discussion about DFA. Example number 2. So we're going to construct a DFA that accepts sets of all strings over 0, 1 of length of 2. So our alphabet is 0, 1, while the length again is 2. So the possibilities will be 0, 0, 0, 1, 1, 0, and 1, 1. This example is very easy. We're just going to determine how many sets or states needed for the acceptable strings. Okay, so let's start with the first or the initial state, which is A. Okay, regardless what is the value of the first symbol, will it be 0 or 1? It will just go to the next state, which is B for our first symbol. And for our second symbol, again, regardless what is the value, it will go to C, which is the final state. Okay, so 1, 2, length of 2, therefore final state. But in case if the length is more than 2, what will happen to those strings? It should be trapped so that it will be considered as rejected. Okay, so third symbol up to the more than the second symbol, okay, it will go to a trap state, so which is D. Okay, again, any values after the second symbol will go to D. And if the symbol is already in the D, whatever the symbol after it will just loop within D. So D is our trap state. Okay, so this is a simple DFA that allows this rule. So let's try to determine if this input is accepted or 1. We have 0, 1. So from A to B, regardless what is the value of the first symbol, it will go to B. And from B, regardless whatever the value of the second symbol, definitely will go to C. And since this is the second symbol, we stop. And since we stop in state C, therefore 0, 1 is accepted. Another example, 1, 1, 0. So from A, carrying 1, it will go to B, again regardless of the value. Then from B to C, and then C to D for the third symbol. Since we already process 1, 1, 0 within our automaton, and it ends with the trap state, therefore 1, 1, 0 is rejected. Another example, 1, 1, 0, 1. So we have 1 from A to B, B to C, 1, and C to D, 0. And after the third symbol, it will just loop within D. So for the fourth symbol, so loop within D, so it will stop in D, which is a trap state or a dead state. Therefore, 1, 1, 0 is rejected. Okay, so it means this automaton is working for the language that we've stated. Okay, now let's define the 5 tuple in defining this automaton. So for the states, list of states, so we have A, B, C, D. For the alphabet, 0, 1, initial state A, final state is C, and this is the delta function, wherein it shows the path based on the string or based on the value, okay, it encounters. Okay, so that's it for this video lecture. See you on the next video lecture, more on DFA. So thank you.